Hello, everyone. Thanks for being here. We are going to start the short paper session in computer track. We are going to have 10 papers to be presented. We are going to watch a 3 minutes video, and after we have 2 minutes for questions. Please, the audience can share questions on Ruva during the video presentation, and after the presentation, I will ask for the presenters. Feel free to ask everything you want. So for start, we have the first paper called Combine Constructive Procedural Dungeon Generation Methods with Wave Function Collapse in Top-Down 2 games. So let's go.
Hello, my name is Pedro, and I'm going to make a brief presentation about my work, which is combining constructive procedural dungeon generation methods with wave function collapse in top-down 2D games. Wave function collapse has been used in the industry since 2016, but in academia it hasn't been explored so much. And because of this, it's actually a relatively unknown algorithm. We have 3 objectives, but the main goal is to show how we can combine WC with other dungeon generation algorithms to create very diverse dungeons without much effort. We are doing this because the interaction of WC with other dungeon generation algorithms hasn't been well explored in other works. So here's one example of WC being used in the industry, in the game Keys of Cud, which uses WC to generate internal architecture for some of its dungeons. So first of all, we have many constructive dungeon generation methods that are very well known and that are used in many games. And we are going to combine them with wave function collapse to create more diverse dungeons than what we see here. So WC works by taking a smaller input and then generating a larger output that's locally similar to the input. And in our implementation, we adapted WC to work directly on tiles instead of pixel values like it was originally conceived. Finally, we combine both the constructive dungeon generation methods with WC to create very diverse dungeons. WC can be seen in action in the rectangles painted on the screen. Finally, thanks for your attention. In the screen, you can see part of my development game that uses dungeon generation techniques that were presented here in this work.
Okay, we are back now for questions.
Alright.
We have time for a couple of questions. Let me check the chat. We have no question in the chat. So Pedro, I have one.
Right.
Did you compare or test the implementation comparing the original pixel-based with your implementation tile-based, or why have you decided to use this?
Right. So I decided to use the tile-based mode that I implemented because it was actually natural, to use it because it hasn't been very well used, and they mostly use and it was quite fast, to generate one of the combined dungeons with we take like 1 to 2 seconds.
Mm-hmm.
So for a grid that is of the size of 80 by 60 tiles, it's pretty fast, and so I use it.
Okay, great. We have another question for Rafael Valles. I believe you have talked about already. How long to generate dungeons with combined methods?
Yeah, they take like 1 to 2 seconds,
2 seconds. Okay.
so it's pretty fast.
Yeah, great. So thanks, Pedro. Let's
All right.
move ahead for next work. So now we are going to watch a Markovian model for the game of Truco.
Hi, my name is Lana, and I'm going to talk about the paper A Markovian Model for the Game of Truco. Going straight to the point, in this paper, adapted Markov chains are used to find the best game action to be taken by the agent to achieve victory. The game in question is the card game Truco, very common in Brazil. The game has basically four modes: Truco, Envido, Floor, and Play cards. Each mode is represented by two matrices, one for the number of wins and another for defeats. Also, the adapted Markov chain resulting from a search in the matrices can be seen on the right. Age 1 and age 502 represents the player's hands, and the other state represents the unused hands. Each mode has its own state space. The Envido and Floor modes considers the player's points, the Truco modes considers the three cards the player has in his hands, and the Play card mode considers, in addition to the three cards, the order in which they are played. For Envido, Truco, and Floor modes, the agent needs to call, accept, deny, or raise a bet. And in Play card mode, he needs to find the right card to play. The cards are divided into low, medium, and high, and the six states in this mode combine these levels. The proposed modeling represents the natural order of the card's strength and also considers the opponent's cards when calling, accepting, denying, or raising a bet. The implementation files occupy a total of 1.58 megabytes of storage. Therefore, the technique described in this work is a light technique and does not require considerable computational power. Among future works, different propagation and interpolation methods will be used to train the bot and increase its chance of victory. And that's it. Thank you very much.
So thank you, Lana, for your good presentation. I believe this is a very fun work to validate. Uh, how do you think about to improve the model, including others AI models for learning, or to improve the robots that you talked? Maybe a future work.
Yeah, I believe it's in the future work, but some techniques are already being tested, and I believe it's pretty nice because it could be tested with my technique, the
Yeah.
one that I developed, and that's it.
Okay. Okay. Very very nice work. We have no question in the chat, so let's move ahead. Thank you, Lana. Uh, Now the next work is an implementation of the Seven Wardens board game for AI-based players.
Hello, my name is Julio, and my presentation is an implementation of the Seven Wonders board game for AI-based players. First of all, our motivations. In order to be able to use bots to play the game, we needed a testing platform, which could interpret commands and yield results. We also wanted it to be able to accept different implementations, so we could work on separate projects afterwards. This is the game. We have a board called Wonder, some resources like coin, timber, and stone, and the structures. The player begins choosing a Wonder card from the Wonder deck. They'll have 21 turns divided into 3 ages in which different cards can be played. They can build a structure or a Wonder or discard a card to get coins. They can only build if they have the needed materials. The implementation follows this diagram. The game class controls every other one and the iteration between turns. Wonder and card are used to store the deck's cards information. Player is an abstraction of a real player which holds information about the player's state, which is used in this case for the bots. And filer is used to write the game status and read commands from files. The input and output are as follows. The program outputs data to gamestatus.json and commands are read from the player underscore a number.json. The bots read status from game status, choose the next command, and write it in player underline some number.json. And they have to append a single ready to the ready.txt file. For testing, we created a basic agent based on previously mined rules, as well as guidelines available on Board Game Arena website. Our bot changes weights based on the current game configuration. The results are the following. Using a simpler bot that could only choose the first available option, We calculated an average of 70 milliseconds per match, and with a bot that could change weights and make better decisions, we had an average of 180 milliseconds per match. And that's it. Thank you for watching this presentation.
Okay, we are back. Thanks, Julio. Let's see if you have questions in the chat. So in the meantime, what are the plans for future tests or future implementations in this work?
So as I said before in this video, this is for testing bots. So our end goal with a series of works is achieving the Nash equilibrium, which was the previous title of this work. Since this one didn't actually achieve a Nash equilibrium, it was just an implementation of the game so bots could play it. We have to change the title. But we have some plans to make some other works using bots to play this game with several different several different algorithms of machine learning for that. So one of them that I already talked with my group to test was the NEAT algorithm, which I don't actually remember what the acronym stands for, but something with neuro whatever. It's I don't remember the acronym.
And will be the work available for external use? For example, I could use to train my bots?
Yes, it is already available. You can access our GitHub page. I think it's in one of the screens there on my presentation. It's just github.com/dmag-ufsm, and you can access everything there.
Oh, okay, great. Very, very nice work. Thank you.
You're welcome.
So following, we have procedural texture generation based on genetic programming. Let's see.
Hi, my name is Vinicius Assunção, and I will present the following short paper, authored by me and Flávio Coutinho. In this study, we present a procedural texture generator based on genetic programming that provides a set of operations capable of generating an image with similar characteristics given a sample image, but not necessarily with the same features. The main related work is Gentropy, authored by Vince and Ross. Our study differs from it by representing individuals as expressions that return a full image instead of a pixel. Here is the summary of how the algorithm works. Briefly, it receives a sample image as input. Then it creates trees using a set of image operators, parameter operators, and terminals. So it modifies the trees trying to reach a better fitness value. The result is a tree of operations that generates an image. The fitness function is based on the shape and on the color of the image. Here are some results of the algorithm execution, and here are some quantitative results. In conclusion, we reached the objective of creating a program that generates a similar image to the input. Some generated images even added more artistic elements. The algorithm is not able to generate textures from images with many details, or images that don't have well-defined edges, or that have low contrast. In addition, it has a higher computational cost. The present work also created a library for procedural text generation. As future work, we suggest the following items. Thanks for watching this video and see you later.
Okay, we are back. Just a reminder for the audience that is chatting on YouTube, please send the questions as soon as possible during the presentation because we have a lack of almost 1 minute between the live. So sometimes I'm not able to get your questions. So, Vinny, did you thought or test a way, for example, or think about to have like an API to allow me to connect with your system and to generate the texture for my game or my work or something that I could use?
I didn't think about that, but that's a good idea. because I created a framework for generating textures, and we have a lot of operators, and it's a good idea. Maybe it could be a future work.
Yeah,
And
good.
that's it.
Yeah, we have one question from the YouTube. What other patterns could be used to generate the textures?
Yes. Sorry, I didn't get.
What other patterns could be used? Do you use some pattern to generate the texture? Can you change your method, maybe? I think this is the question.
Okay. And let me think. Maybe I could use other operators. For example, I can use. For example, I used I my algorithm used represents an image like it use an image and apply few operators on it. I could use just my just a pixel and work on this pixel. For example, my individual could be represented just for a pixel instead of an image. Don't know if I answer.
Yeah. Okay, no problem. So thanks, Vinicius. Thanks for your presentation. Let's move ahead. So the following work is the spatial distribution of agents in virtual terrains through search and of optimization algorithms. Let's watch.
Hello, my name is Felipe Pires, and today we'll be presenting the spatial distribution of agents in virtual terrains through the search and optimization algorithms. This article is inserted in the search field of simulation systems. Such systems are often used to reproduce context real-world tasks. Similar to this type of systems, real-time strategy games become a popular search field. There are many applications for artificial intelligence. Because of the similarity, both fields can share all the knowledge researched, mostly in optimization and behavior of agents in the virtual environment. The purpose of this article is to solve the problem of distribution of agents in the virtual environment, where some restrictions have to be met. The problem needs to be completed within 1 second and 10 seconds time limits, and the position of the agents must form a circular spatial distribution. Both simulate ending and taboo search can escape the optimal locations to find a better solution. This occurs by accepting worse solutions in order to find a better solutions. They use a technique to always accept the better solution and may accept the worst solution. Simulate ending uses the probabilities to accept the worst solution, and taboo search uses the taboo list to prevent solutions already evaluated. In order to build a valid niche solution, a constructivity heuristic is used. A minimum radius and angle between agents is calculated and used to define reference points around the circle. The terrain feature closest to the reference points are chosen to be the positions of the agents. After the initial solution is completed, the meta heuristic modifies the positions of the agents, seeking a combination of positions that form a circular distribution. Experiments were performed in 500 completely different scenarios. All the generated maps had different distributions and quantities of terrain features. Each algorithm was submitted to a search and optimization competition for different organizations composed of 10, 20, 30, 40, and 50 agents in a limited period of time of 1 and 10 seconds. Here, the error results from 1 second and 10 seconds from simulated and search, and here the circular measure for simulated and search. With restricted processing time limits, the tested algorithms achieved this spatial distribution for the agents in different virtual terrain scenarios, where the solutions were close to ideal distribution. Double search showed the better results in longer processing time and in a large number of agents in the spatial distribution, and simulated ending showed the better results for a smaller number of agents in the spatial distribution. Questions?
Okay, we're back. We have Felipe here for question. While people maybe typing questions, I have one. Have you tried or test higher number of agents? For example, may I work with large groups or even a crowd?
Yeah, I tested one time just for curiosity, and with larger number of agents, uh, some algorithms can be not satisfy the restrictions.
Oh, okay, yeah. I just asked because I love crowds. Okay, I think we don't have questions from the audience, so we may move ahead. Thank you, Philippe. Very, very nice work. So following, we are going to have player focus tracking based on computer vision for game analytics improvements.
Hello, my name is Alison, and today I'm going to present a paper called Player False Tracking Based on Computer Vision for Game Analytics Improvements. We believe that emotional feedback can help developers enhancing their understanding of gameplay, and to do so, we developed a model that analyzes players' facial images collected during gameplay and detect players' emotion as well as screen focus. So we expect that our model may help developers to get better information about their games while in the testing phase, allowing assessments of player satisfaction based on emotional engagement and feedback. Our model consists on collecting real-time player attention and focus data through player images processing. For grabbing information about player satisfaction, we use emotion transitions, and our idea is that we have good emotion transitions and bad emotion transitions. So we developed this API where developers can send these adjacent matrix, and the system uses these ways to calculate the score. To screen focus, we use these landmarks as inputs to a fuzzy model where we can find players' head position. Our results shows that we can find levels where the player is not so interested or immersed in the game. Other thing we can see is, for example, we can use the satisfaction score to find better and worse levels. So developer can look to this kind of information and maybe rework this room. Our conclusions so are that we could find these insights that we were looking for, and using it, we can apply gameplay tests in scale without the needing of a specialist looking to the player while he plays the game. And we think that we could improve our results by adding more emotion. So that was our paper. If you have any question, I will be answering. And if you want to talk to me, here's my email address. You can contact me anytime. Thank you.
Thank you, Alison. We are back for questions.
Hello. Good
So
afternoon.
I was wondering, this is available for use or application in test development. Did you know something about to use this kind of technology for get production data regarding privacy and security? Because you are talking so much about data. Do you have thought about that?
Yeah. So our main goal now is to try to figure out a model that we can use to collect player data. Uh, and the idea is that we use it while testing because usually when you develop a game, like you go to an event and you let players play your game, and then you watch them playing and do like game flow testing and things like it. And our idea is to automate these kind of tests to be able to do it widely, right? So uh, we would probably need to have a good privacy contract or things like it to be able to use it with real world products. Yeah, but our idea for now is trying to understand if we can do it. So if it's possible to have this kind of information and then try to use it with commercial games.
Yeah. We have one question from the chat from Luis. He's asking, did you think about using emotional models? I don't know if you already are using some literature model about emotion or thinking about to use. It's a good question.
Yeah, good question. So, thing is, usually when you are playing a game, you don't express yourself so much as like if you were acting or if you were in a movie, right? Uh, so m- most user expression, face expression models and data sets uses movies images or model images. So we are having trouble to find smaller changes in expressions to figure out the emotion people are feeling. So that's our problem with our emotion models right now, and we try to prevent this kind of thing by doing this adjacent matrix where we don't count the emotion itself but the transition, right? So
Mhm.
every time a person change the emotion it's feeling, so we count it as a good or a bad transition. So that's our idea to try to prevent this problem, but it's actually a really hard problem, and that we are trying to solve it, and we couldn't find many data sets that helped us training uh, uh,
Mhm.
convolutional neural network models to do this kind of prediction.
Yeah, yeah, yeah. Maybe you should build one. I'm asking
But
because I'm very emotive when I'm playing.
yeah, that's a hard thing, and that's a point where we are starting to see that our project may be very useful right now because usually I would go to my university hall and then place some cameras and computers and ask people to play or take photos of them. But now with this uh, social distancing thing, it's being quite hard to get this kind of data, and so you must have people with not only not only people that want to help you to give you the data, but also that have hardware and have things that can catch these images and things like it. So it's pretty hard.
Yeah, yeah. Yeah, you have lots of future work to do. Very, very interesting. We could be discussing for 1 more hour,
Yeah,
but thank you, Alison. Very nice work.
thank you.
So, following, we are going to watch improving FIFA free kicks player agent performance through object detection techniques.
Hello everyone, my name is Matheus Faria and I'm from Federal University of Berlândia, and now I'll present our paper. Here's the agenda of the presentation and let's go. So basically we are dealing with deep reinforcement learning agents based on deep Q networks that play the free kicks mode in FIFA. We are using a simple scenario in which there isn't a goalkeeper and there are situations with and without barriers. Here's the general architecture of our agents, and we are trying to improve the object detection model. It's important to point out that the agents can move the camera to the left or to the right and make a low kick or a high kick. And our paper is based on Trivad work, and we made two modifications on his approach. The first one, we used a newer feature extractor, and the second one, we included the barrier on the elements identified by the object detection model. So these two modifications are the objectives of the present paper. And we divided our experiments into two parts, training and test phase. And we trained each agent over 1,000 episodes. And one episode ends when the agent makes a low kick or a high kick. And we evaluated them in terms of the rate of goals and training time. Then we tested each trained agent over 10 sessions of 100 episodes and evaluated them in terms of the rate of goals. And the results showed that the agent that implements our modifications outperformed the other two agents. And now we are working on an extended version of this paper. So thank you for watching the presentation, and feel free to ask me any questions or make any suggestions. Thank you.
Okay, we are back. Thanks, Mateus, for the presentation. I'm curious about the extended version. What are in your mind for the future work?
Okay, we have been working on a newer and alternative state representation, and that is more easier to understand for a human and for the machine too. And that's our main objective now, is to increase the rate of goals of these agents and try to get some good results with this.
Yeah, and how easy is, for example, to me include my agent if I would like to implement an intelligent agent and use your model to validate it?
Okay, we made our own interface to connect our agents into the FIFA game. And basically, you can use our interface too. It's very easy to use. We have a paper about this too, so it's very easy to include your agents.
Perfect. We have a question from the chat from Professor Bruno. Do you have plans to incorporate aerodynamics effects and especially aeroelasticity?
Honestly, we didn't think about this,
Yes.
at least for now, but it's a very good idea.
Yeah, it's a good point on simulation. Great. So thanks for your presentation, Mateus. Nice work.
Thank you. Bye.
So the following paper is Towards Automated Team Composition in Mobile Games Based on Players' Personality, an Intelligent Approach.
Hey guys, my name is Lincoln and I'm here representing my colleagues Aline and Francisco to present our paper called Towards Automated Team Composition in MOBA Games Based on Players' Personality and Intelligent Approach. MOBA games usually have 10 players divided into two teams fighting for resources with the main goal of destroying the enemy base. Here on the left we have the map of League of Legends, one of the greatest titles of this category. On the right we have the 5 holes that players can fill on each team. They are support, jungler, mid lane, attack damage carry, and top lane or off lane. Our approach is based on genetic algorithm applied on a database containing 147 samples of player data. We applied a data preparation step to normalize the values and remove unnecessary information, and after that we use this as entry for the genetic algorithm. As a result, we expected to have an adequate team considering roles restriction and considering players' personality traits in game and Big Five ones. Mobile games have a lot of similarities with traditional sports such as football, basketball, and volleyball, in which players who have complementary behavior traits, in addition to their skills, will get better results. Thus, our goal is to find a team with specific personality traits considering real factors and the behaviors into the game. As mentioned before, GA was applied in a database composed of 147 samples that represent the players. Here we have a small slice of our database containing informations like nickname, ranking that was normalized, role, Big Five personality for this player, and game personality for this player. Our result achieved 100% considering the fitness function created for this problem. But with around 20 generations, we could reach a great fitness value of around 85%. That's it. Thanks for watching.
Okay, we're back. Let's check if you have some questions from the audience. Not yet. Lincoln, do you have plans to use examples with other games to test your approach, or it's very specific?
No, we have plans, and this is just a small slice of our work. And I'm interested on analyzing all MOBA games and things like team composition and win prediction. I want to analyze all the data we have available to us to make it the better approach we can. So yes, we have plans to test on data on mobile games that they are rising.
Yeah.
Actually.
Did you use your own dataset, your build dataset, or there is available datasets to be used?
Both. They are available, but since we made our own game personality, we used Big Five and we made our own, and we created a survey, and that's how we get all those samples from real players.
Oh, okay. Yeah. I believe we have lots of volunteers to participate. Yeah. So,
For sure.
yeah. Thanks for your presentation, Lincoln. Very, very nice work.
Thank you.
So following, we have application of fuzzy logic for creating a game flow qualification model. Let's watch.
Hello, my name is Vitor Hugo Velter, and I will present the article called Application of Logic Fuzzy for Creating a Game Flow Quantification Model. As seen in the title, this work had as main objective the development of a game flow quantification model using fuzzy logic. The application context used was the League of Legends, and the model was divided into two major stages. First, an online questionnaire, and second, a fuzzy system. First, the online questionnaire allowed the participants, the law players, to provide information that made it possible to analyze League of Legends by the game flow model, and also to define the most promising variables of game flow, which were selected: champion selection, kills, team composition, dragon kills, and baron kills. For the fuzzy system, was used a fuzzy controller that had the five variables previously selected as an input, and also the game flow output variable with a value from 0 to 100. In this step was also created a decision tree to define the rules used by the controller. This image shows an execution of the model where returned as a result a game flow value of approximately 67. As a result, the testing stage was divided into two approaches, one using only the last game of each player, together with the information whether the game was fun or not, and the second is to using a historical analysis of the last 10 games of each player. Thank you.
So we are back now with Vitor for questions. If you in the audience have questions, feel free to ask. Vitor, in the meantime, I see your model looks very, very interesting, applying different techniques from AI. As I asked in the previous work, are you interested or you have tested with other games?
Hello. No, we tried it just with League of Legends to try to build a consistent model, but in the future we have plans to maybe try another games, like start with another MOBAs and then use the information of other types of games. But in first, just League of Legends.
Yeah, because we could compare different behaviors, could be an interesting research point.
Yeah.
Okay, let me check the chat. No question for now. So thank you, Victor, for your presentation. Very interesting work.
Thank you.
So now I have the last paper of the session, which is evaluating video game acceptance in game reviews using sentiment analysis techniques.
Hello, my name is Larissa, and I'm here to present the work Evaluating Video Game Acceptance in Game Reviews Using Sentiment Analysis Techniques. The advancement in technologies and the emergence of social networks, smartphones, and tablets make video games even more popular and accessible to different audiences. To be successful in this competitive market, a game developer needs to know the reasons that lead customers to play a game and how to keep the players engaged. With the internet and social networks' popularization, users can express their opinion and sentiments freely, providing feedbacks. Sentiments expressed by the users about different aspects of the game have a strong correlation to the user's acceptance of the game. In this work, we evaluated video game acceptance using sentiment analysis approaches. A new dataset based on game reviews in Brazilian Portuguese is proposed, and the dataset development process is described. The proposed datasets are analyzed and classified using three well-established classifiers from text classification literature. The experimental results pointed out that support vector machines and logistical regression are able to achieve the best performance. By analyzing the most frequent words, we could have a better understanding of how players feel about a game. In future, we intend to extend this work by analyzing how the game acceptance varies with time as an attempt to understand how game changes and updates can influence the game acceptance by its users.
Okay, we're back. We have no Larissa, we have Luciano now. So Luciano, one question I have. Did you try it already, your data sets? Which word was the best word or the best conclusions you could have?
I didn't understand. Could you repeat, please?
I was wondering to know more about the tests or the use of the data set, what you already discovered about.
And you are asking about the dataset. We collect the dataset from Stream, and the dataset has already been labeled. Is that your question?
Yeah, but
how we get the dataset and how we analyze it. Is it? Is that correct?
Yeah. Go ahead.
Our evaluation has been based on the user's classification. The data has been labeled before the use. We collect about 2,000 data, 2,000 reviews from the users in Portuguese, and we divided the reviews in positive and negative, and the classification has been taken into consideration that preprocessed data.
Okay. We have some questions from the chat. First question is from Professor Bruno. He says, the size of the data set is crucial. What are your plans to deal with that?
We are extending the data set currently. Actually, nowadays we have about 10,000 data collected yet from streaming Brazilian Portuguese because we are evaluating the Brazilian users specifically in this work. But we are thinking about extending for other languages like English because we have a greater repository in English language.
Yeah. Okay, people like the work. We have 2 more questions I'm going to do at the same time. There are some specific game review characteristics used in the sentiment analysis. And what's the key points of using sentiment analysis in contrast to other more standard methods?
Well, we need to understand how the users are thinking about what they feel about the game. So sentiment analysis could lead you that way. So we can use sentiment analysis combining with other game analytics or metrics and combine them to complement the information we have about your users that is crucial for the success of your end game, I believe.
Yeah, good. Okay, thank you, Lucian. Very, very nice work.
Thank you very much.
Okay, everybody, we are finishing our session. Don't forget about to join the Discord server to keep the conversation going with the authors and participants. And see you in the next section.